Node.js comes with an array of powerful prepackaged utility libraries called core modules. Because these tools are built directly into the Node environment, you do not need to install them using npm like you would with external dependencies. When importing a core module, you use standard syntax for either CommonJS or ES modules, but you omit the relative file ./ You simply import the module by its direct name string. 3 of the most common core modules are OS, which stands for operating system, path, and fs, which stands for file system. Let's import each of these, and then we will talk about how each one works one at a time. For CommonJS, you create a constant and use the require function. And we can set up each of these exactly the same way. Again, we don't need any kind of relative path here. We just name it, and it comes directly from the built-in Node core modules. If you use ES modules with a corresponding package.json file, your syntax will look more like this. Let's look at how to use OS first. The OS module provides code that allows you to interact with your computer's hardware to pull system metrics like available memory or your operating system platform. For example, we could look up the host platform and just say os.platform. We could also look at your username with os.userinfo.username. Then we could use that information to create a diagnostic report. Arcade engine session log. And on the next line, user with current username. And then on the next line after that, host platform. And we're just going to hang on to this because we're going to use it in a minute in conjunction with a different module. As you can imagine, there are a lot of different methods that you could use that come with the OS module. And W3 Schools has some great quick documentation and examples here that you can explore. You can see there's the type of your operating system, release number, your CPU architecture. You can look up your memory, and so on and so forth. I encourage you to explore this and see what else you can do with it. Now let's move on and talk about how to use path. The purpose of path is to stitch together your file strings by making sure that your file paths will adjust to use either backslashes on Windows or forward slashes on Mac or Linux, preventing cross-platform crashes. Now, something that's important is that if you want your destination for the file that we're eventually going to create to be the same folder where you currently are, you need to make sure that that's actually where you currently are in your terminal. So I can check my full path here, and that's exactly where I want to be to make sure that the file we create with the third module, fs, will be placed right here. But I need to do that now because we're going to use path to create that destination. Let's call this safe file path. And we'll use path.join, look up the current working directory. And then for the second argument here, we're going to pass in the name of the file that we want to tack on to the end of this path that we can use in the future to create that file. We can log a statement here, target destination, safely mapped. And then we will take a look here and see how this comes out. Let's go ahead and run it. And it gives us the path that we just looked up plus /log.txt for text. Okay, so we have a string that represents that path where we want this file to go, including the file name. Now we can use fs, a different module, to read and write from our system. So this will be interacting directly with my hard drive to create or delete or change files, whatever I need. First, we're going to write the diagnostic report from here onto the hard drive, creating this new file with this path that we just stitched together. And then after that, we'll read back to see what the file contains. So I'll use fs.writeFileSync. Give it the path, and then give it the content that I want to be stored inside the file log.txt. Now let's read it after it's been created. I'm going to use a synchronous approach to this because we haven't learned about promises yet with asynchronous operations, but you do know about try and catch. So we'll try reading it. We're going to store it in data. Say read file sync. Tell it what the name of the file is that it's looking for. And then make sure we include the encoding here. It's important to do this so that we get a string back. And then we'll log it. Oops, I missed my backslash. Let me fix that. There we go. All right. And then we make sure we have error handling here, just in case something goes wrong, if the file didn't exist, for example, so that the program won't crash. Let's run this whole thing. Okay, so we have our destination mapped. We created the file and stored some text in it. And now we read it and see that it says Arcade Engine Session Log, User, CRJ, and Darwin. When you try this, you'll probably get different answers because you have a different username and possibly a different operating system than I do. So these are just a few simple examples. There is a lot more to explore with all of these, and they can really provide you with some useful functionality in conjunction with programs that you may write, where you need the program to be able to interact with your system. For your practice, you're going to import all three of those modules and then build a local file generator script, and this will walk you through it step by step. That's all I've got on this. I will see you in the next one.